This is my DIY CNC machine. It's pretty good, but could it be improved?
Oh, here we go.
What? Welcome back to the workshop. So in this video series I'm building a CNC stall detection system, so hopefully I don't break any more end mills. So in a previous video we designed this custom PCB and got our first prototype working. This video we'll have a little bit more of a look into some of the detail, some of the fine tuning, see if we can get some of the parameters dialed in a little bit better, and see if we can get the e-stop to fire a little bit more predictably. We'll then add some code to make use of the libraries, so we can store and retrieve user variables, and if it all goes wrong we can also do a factory reset. Let's get started. Welcome back to the workshop. What is wrong with my camera? Welcome back to the workshop. So we're continuing this build series on a spindle stall monitor. So in the last episode you saw me put this together and it was kind of working, but it was a little bit intermittent, and I found there was a fault with the board. I just had to reflow some of the solder joints and then it worked fine. I've also improved the code, so the speed for the spindle and the VFD is really nice and tracks nicely now. Okay, so I want to have a look at a couple of things on this board. The first being the brightness of this LED. So it's driven by pin 1 out of the op amp, and as you can see I've tried a few different arrangements here. It's not super bright, but I was worried about putting too much current into the microprocessor because it's the same signal. Some of it's going that way, some that way, and I wasn't quite sure what was going on inside here to work out the resistances. So first thing I want to do is have a little play with the LED and see if I can get this a little bit brighter. Now the one that runs off the inverter, the PWM signal, comes live from the 10 volt signal. It's just got a resistor in series and that's plenty bright enough. It's just this one that's comes off this op amp that I want to have a look at. I tried a few different arrangements of the LED and the resistor and where I was putting the signals, and trying to get the LED to be bright and still get a good input into the ESP32 so I'd get an RPM reading. But in the end I gave up. I just couldn't get it to work at all. So I think what I'm going to do is dedicate a monitor pin, so one of the other pins on the ESP32. I'll have that pulsing a PWM signal out like a slave pin. So the main signal that comes out the chip here that's measuring the speed, that will be processed and go into one of the pins, and then in software it will pulse out via another pin which I can control much more accurately, and I can get a nice bright LED. So I'll kind of separate the functions. Along the way I did try changing that chip out, so that's the TL082. Try to put the 741 chip in. I didn't get any response at all. I monitored all the pins and I was getting an input, I was getting my reference voltage, I was getting the power, just getting no signal out at all. So I wonder if I've got a bunch of fake 741s. I tried a comparator chip as well, a different one, and I got the same thing. I didn't get any output at all. So have I got unlucky and on two completely separate occasions bought two fake chips, or two sets of fake chips? I don't know. Anyway, I'm back round to the TL082 and it's working, so I'm going to abandon trying to make this any better. We'll just put it back as it was for now, and in the new version we'll implement that monitor pin as I just mentioned a few minutes ago, and then we'll get the best of everything. We'll get a nice clean signal and we'll get a nice bright LED. Right, let's go and do that, and then we'll have a look at the speed signal. Okay, I've improved the code so it does some averaging and a little bit of smoothing as well, and now the spindle, the actual spindle and the demand RPM are pretty close. So let me just run that up, and also they don't jump around too much. Let's go to about 4,000. Yeah, reasonably stable. Alright, let's go 5. Pretty good there. Let's go to 10. Yeah, happy with that. Alright, 15. Just over. There we go. Okay, not bad. Maybe a little over there. 20. Okay, 20, or full. Should be about 24. It's just dropped off a bit there. Watch me make it worse. No, that's probably it. Alright, spool down. Right, so I'm pretty happy with the readout. It's pretty steady and quite smooth. The only downside is, because it's got some smoothing and averaging in it now, if you stall the spindle by hand, you'll bring it to a halt pretty quick. It takes quarter of a second, half a second for this to catch up and to read that 0 value, or read a much lower value. So it takes, and that's what it's using for the e-stop. It checks to see if these are different enough and if you're decelerating fast enough. So it's used those two parameters in the algorithm. And it's causing the e-stop to be a little bit slow. So I need to go away and think about how I can kind of make both those systems better. So I've got one more minor issue which I want to resolve. I think this one's a bit easier. So when you switch the inverter on, it sends a pulse out through here, or probably a couple of pulses, and it gives you a reading on here of a certain RPM. And of course this system then sees a high RPM on the demand but nothing on the spindle, and it thinks the spindle is therefore stalled, and it goes into e-stop, which is a bit annoying. Wait for the fan. Okay. Yes, it showed a difference, but it didn't trigger the e-stop, so hopefully that's worked. Right, let's manually do an e-stop and make sure that still works. So we'll run at low speed and I'll try and stop it. Yeah, see, it took maybe half, 3/4 second to actually stop, which is a bit slow. So we need to work on that next. I'll play around with the number of averages, running averages. I'll try and minimise that on the spindle and see if it will react a bit quicker. I think it should do, but let's see what happens. Oh, while we're in there, we'll just show you, I'll have a look. Spindle averages 2, VFD averages 5. So it doesn't matter if that's smooth and runs a little bit behind. What's key is the spindle keeping up. So let's give that a go. Right, come out of there and we'll try it again. Let's start it up. In fact, before we do that, let's just move the RPM around, just see. Yeah, it jumps a little bit more, doesn't it? Still pretty good. So if I switch it off, that will spool down quicker. Yeah. So because there's fewer averages there, it spools down quicker, so the difference between them triggers an e-stop. Let's just try it again. Switch off. Yeah. Alright, well the obvious thing to do I guess is to reduce the averages on the VFD. Try it again, start it. Switch off. Okay, so they're going to have to be pretty similar. Alright. Moving the speed around. Yeah, with less averages it's out a little bit. But the main thing is, what's it done to the e-stop? So we'll come down to just over 1,000. So I don't hurt my fingers. Alright, somewhere there. And we'll stall it and see what happens. Alright, go 3, 2, 1, stall. Right, well in the editing software I'll try and do that in slow motion and just see how long that takes. I might go with that, it wasn't too bad. Let's try one more. 3, 2, 1. So while I think about that, the other option is the sample time. So that's 250 milliseconds. If we go down on that, let's go 200. You know, it has to have a certain amount of time to sample and count the number of pulses and then divide by the time that took, and to work out the RPM. It's not an instant reading. Let's try that. I'm feeling this might start to wander too much. Let's see. Okay, pretty good there. Yeah, you can see that one jumping around a little bit. Okay, let's try stalling it and see how long it takes. Just go to just above 1,000. Okay, let's try that. Three, two, one, stall. 3, 2, 1, stall. 3, 2, 1, stall. Alright, just made a few more minor changes to the program, and I was just thinking, so because these are averaging quite high now, let's just check what they're on now. Yeah, back to 5 averages, okay. I can probably back off this to make it more sensitive again on the E-stop, so hopefully it triggers the E-stop before spindle actually stops rotating. So we'll play around with that, but because I made some few minor changes to the program, we'll just make sure it's still kind of E-stopping at some point, and then we can use that as our baseline. Right, glove back on again. Okay, let's start the spindle. Try and stall it. Okay, 3, 2, 1, out. Yeah, it's taking quite a while, isn't it? 3, 2, 1. Alright. So it's definitely stationary for a short amount of time. Let's go in the menu. And we'll reduce that. Let's go 40%. Right, so now I see there's a lot more stars, so it shouldn't take much speed differential for it to go into that zone. Right, glove back on. Okay, stalling. 3, 2, 1, stall. Oh, that still went a long way up. Hold on. Right, 3, 2, 1. I wonder if the stall counter in there I've added is messing it up. Right, hold on, let me change that. Right, I realised I had another parameter in the stall detection, so if it goes around the loop, detects a stall, it increments the counter and then comes back around again, does more sampling, calculates the RPM, delta and so on, and then it adds the counter again, and if that counter got past about 2, then it would e-stop. So again, it's putting some lag in the system when it was really jumpy, but now we've got it smoothed out. Basically it won't have any counter at all, so as soon as it thinks it's got an e-stop, it should trip the system. So let's try that again. Let's see, we're still on 30%, so it should be pretty sensitive now. 3, 2, 1, stop. It still seems to be taking a while. Right, just change the code, so essentially it's just going to monitor the load bars directly and check if they go into the stars rather than loads of other sort of calculations it was doing. So it's just uploading that. Go back on, and when that's done, we'll try that. Okay, here we go. Three, two, one, stall. 3, 2, 1, stall. Seems a bit better. 3, 2, 1, stall. 3, 2, 1, stall. 3, 2, 1, stall. Yes, pretty good. Perhaps tune that a little bit, but that's better. So what have we learnt from that? Well, the averaging for both the spindle demand and actual need to be the same, so they've got the same kind of slew rate. Otherwise, you're in danger of having one get out of sync with the other. You know, one being more realistic than the other, then there's a bigger delta, and it thinks you've got an e-stop condition. So matching those is good. Having the sensitivity dialed up a bit now because the RPM averaging smooths things out and puts a bit of a delay in. That seems to work. I've got the tripping or anti-trip so that when you switch the inverter on or off, it realizes what's going on and it doesn't send it into an e-stop, so that's working. So I thought it was about time that we updated the schematic with everything we've learnt, so when I make the next board I'll have all those changes incorporated. So we're looking at the op amp there, and then if we jump over to the main board design, so one thing you'll notice here is when it fires up, I've separated out the LCD screens on a separate board, so we've just got the main processor here with the chips, filtering and so on. And if we dive in close, you can see I've added the silk screening to a lot more of the pins. It just helps when you're assembling and debugging. We can also have a look at the nets here. So these are the individual routes that go to the different components or different systems. And again, it just makes sure, you know, the software will just check that you've definitely got something connected to each end, and a few basic checks like that. Sometimes that can catch you out, so it's great to have that function in here. And then if we go back to the main PCB, you can actually zoom in on some of the tracks, like this one here, and you can actually see what each of those nets is called, where it's going. Again, another check just to make sure it's wired as you expect. I tend to use the auto router. I found that works pretty well for me. And then if we have a look at the 3D view, I've got most of the graphics loaded in, so it actually can populate the board and it makes it look pretty realistic. So again, it gives you a nice overcheck to make sure, yep, everything's included. I don't have an ESP32 in there, but I think you can imagine what that would look like. And I've got the reverse side silk screened as well. So let's jump across and have a look at the separate LCD screen. So this is the schematic. It's pretty straightforward. So we've got our screen there on the left. And on the right, I've decided to use these JST PH connectors. So there'll be a 10-pin version, a 2mm spacing. Gives me some flexibility on where I actually put those because they're quite small. Here's the layout. So not much to see. There's our connector on the left. We've got another one on the right, so we can have different wiring, harness, routing. It can come out the top of the board or the bottom, whichever I need. And then here I've got a voltage divider, so that drops the keypad output from 5 volts down to 3.3, which the ESP32 will be a lot happier with. Again, if we jump across into the 3D view, not too much to see here. You can see the resistors on the right there. And I've got headers on here, but I think in reality I'll go straight to the board. This hole here and that one there is so I can 3D print a little spacer to support the keypad. And then on the underside you can see those connectors. So look out for those new boards in a future video. Now back to this video where we need to look at saving the user preferences. Okay, so I've added a little bit more functionality to the code, so now it's using preferences to store all the user variables. So that means when you switch it off, switch it back on again, it remembers all your settings. It's also got the option to go back to factory reset, so it can go back to the default values if you want. So when you switch it on, you just hold down the select key and then it goes into factory reset. Okay, so first of all you can see I've got the system hooked up here, so if I just take the USB lead out and then I'll plug that back in. Try and do it, the camera's in the way. Splash screen, then we're loading values from the non-volatile RAM in there. And then if we go into the memory, or menu, sorry. Here's all our values, sample time, averages, whatever. Let's just change the averages then. Let's knock that down to 2, let's say, and we come out. When we come out of there, saves it back into the non-volatile memory. So that was 2, wasn't it? So if we go back in, obviously that is still, oops, wrong button. That one. Okay, so that's still 2, come out of there. And then if we switch it off, actually I'll just unplug it up here, it's a bit easier. So we'll take the USB lead out, plug that back in, boots up, loads our variables, and then if we go into the menu and go across, it was, yeah, VFD averages. Okay, so that all works. It's stored the value I set before, and then the other test is we'll do a boot up. So again, I'll take the USB lead out of here, it's a bit easier. I'll hold down the select button and plug it back in. So we go get factory reset when we let go. Resets all the values, and then we'll go in there, and it was that one, wasn't it? Yeah, it's back to 5 again. So it'll go back to whatever I put in the firmware. Alright, so yeah, it'll save. So pretty pleased with that. I think that makes it quite nice and be a bit of a pain just to keep losing all the values. Right, so that's our preferences menu. So in the last video someone did ask which solder I've been using, and to be honest it's just some generic stuff off eBay, but if it helps anyone, that was the label. So you can see the composition down there. And lead-free solder. Got 2 reels of this, it seems to work okay. Okay, so we've got to a pretty good point in the project. You can now store the user variables in memory so you don't lose them. You can go back to a factory reset. The parameters themselves look within tuning range. I think we'll only really know where we're at once we start cutting and trying out the e-stop to see if it's quick enough. So I think we'll call the video there, and I'd like to say thank you very much for watching. Thank you for following along, and if you want to see where we go to next, I've got the next round of PCB on order, and in fact it's literally just arrived this morning, so I'll have a look at that next. Slightly different layout to what we've got here, so the next evolution of it. So if you don't want to miss that, feel free to subscribe. If you've got any queries, questions, comments, feel free to leave those down below as well. And with that being said, thank you very much for watching, and see you next time.